Okay, so for today's lesson, before we move on, I have two problems of the day for you. It says graph the following on the whiteboard. I left that in the notes. Sometimes in class I've had people use the whiteboard. So right now, problem of the day is just to graph these. Make sure we're okay with graphing. All right, so you don't actually have to use it on the whiteboard. You might be wondering what happened here. We actually went from lesson 2.3 to 2.8. And 2.8 is called Graph Linear Inequalities in Two Variables. And honestly, the reason why I ordered it that way is I think it fits a little bit better to talk about graphing in 2.3. And then 2.8 is also graphing the same thing, but we're adding, instead of an equation, it's an inequality. So it fits a little bit better with, I think, how we go through the material. So no, we didn't talk about lessons 4, 5, 6, or 7 yet. That'll be the second half of the chapter. So a linear inequality in two variables can be written in one of these forms. Ax plus by less than c, ax plus by less than or equal to c, ax plus by greater than c, ax plus by greater than or equal to c. So you have your four inequalities, right? Less than or equal to, greater than or equal to. The solution to them is an ordered pair that is a solution of an inequality that is true when the values of x and y are substituted into the inequality. There is more than one correct answer for this. It's going to be a range, or it's going to be a region of points, I should say, not just a single point on the line, all right, that we're used to so far. So example 1, which ordered pair is a solution of 5x minus 2y less than or equal to 6. Take a minute. I will talk about what the answer is. I want you to pause the video. What you're going to do is you're going to take each ordered pair, there's 4 of them, plug them into the original, and see which inequality statement is true. So I want you to do that first before I give you the answer, so make sure you pause the video. Now, if we go through our answers, hopefully you chose letter A. It's correct. All right, so the answer is A. And here's the work for that. I'll actually type it here. So we plug in 0 for x and -3 for y. And you get 0 plus 6 is less than or equal to 6. Or 6 is less than or equal to 6, which is true, right? I mean, I know it's the same number, but it's less than or equal to. So it could be equal to that number. If you tried them all, the only one that would work would be letter A. All right, and this is important as well, because as we do the problems here, we're going to have to test certain parts to do shading that I'll get to shortly. So, all right, let's talk about what the graph of a linear inequality in two variables looks like. And here's a picture right here. It says set of all points in a coordinate plane that can represent solutions of the inequality. So up until this point, you had a line. See, here's our line here. It'd be a solid line, and that's it. The only points that worked were the points that were on the line. Now what happens? You could have a solid line, you could have a dashed line. This is dashed in the picture here. You could also have a region that is shaded. All right, so now we're adding more to it. So if we look at the picture here, I talked about what an inequality graph is. We're adding to a linear or line graph, linear equation. If you read off to the left here of our picture, it says all solutions of 3x minus 2y greater than 2 lie on one side of the boundary line, 3x minus 2y equals 2. So it lies all over here. What's interesting is if it was or equal to, it'd be a solid line, but it's not or equal to, so it's dashed. The boundary line divides the plane into two half planes. The shaded half plane is the graph of 3x minus 2y greater than 2. All right. Next definition, dashed boundary line. The points on the line are not solutions. So as we see here, none of the numbers on the ordered pairs on the line would test in that inequality. And solid boundary line, the points on the line are solutions. So how do we graph a linear inequality? All right. Step 1, graph the boundary line for the inequality. Dashed line is less than or greater than. Solid line is less than or equal to or greater than or equal to. So you graph it just like you know how to graph a regular line or an equation of a line. Step 2, test a point not on the boundary line to determine whether it is a solution of the inequality. If it is a solution, shade the half plane containing the point. If it is not a solution, shade the other half plane. And I added a little note here. You can use 0, 0 as long as it is not on the boundary line. I like to use the point 0, 0 because mathematically, for the most part, it's easier just to plug it in and solve because the numbers cancel out. But be careful because you could only use it if it's not on the boundary line. Sometimes it is. So it's to be a point separate from that. All right, so we're going to start with the basic one. Graph x less than or equal to 5 in a coordinate plane. So I first start the x inequality. I would think of it as x equals 5. And if you remember back, be careful. It's either going to be a horizontal or vertical line, right? So think about that for a minute. I start plotting at positive 5, so to the right 5. 1, 2, 3, 4, 5. So here's my point. And in this case, it's going to be a vertical line because it's x, all right? So when we set this up here, I got to ask myself, step 1 said, is it a solid or dashed line? So I know my line is going to go vertically up and down through the point 5, x equals 5. If I look, it's less than or equal to. So it's or equal to, so it's a solid line through this point. All right, so that's step 1. Step 2 tells us we have to shade. Now, in this case, it talks about half planes, and you can't see it all here, but here's a half plane on the left, here's a half plane on the right. And I mean, I'm only giving you a part of the graph. I mean, we can make it even. It doesn't have to be, though. So part 2 is I have to test a point. Actually, I always check, can I test 0, 0? Let's plot it. I actually graph it on the coordinate plane. All right, it is not on the line of this equation here. So I am allowed to actually test 0, 0 into my original to see where to shade. If 0, 0 is true, I shade where 0, 0 is. If it's false, I shade the opposite. So I want to see when you do these problems, the point you test 0, 0 I'm using. Now it might be a little odd with this one because you see how there's only an x, there's no y. Don't worry about that. If you're plugging in the point, plug in the only number that you need. So x less than or equal to 5. I plug in 0, 0 less than or equal to 5. And this one I don't really have to solve, right? I mean, it's sort of solved for itself. Think to yourself, is this a true statement? Is 0 less than or equal to 5 as an inequality? You can find out, yes, it's true. So I always like to put a little check mark there. So if it's true, I'm going to shade where 0, 0 is. So here's 0, 0 right here. It's true. So here's my shading. This whole plane to the left. And probably will do a better job at shading than I am, but you get the point. All right, so that's my graph. So what's extra? Is my line solid or dashed? And I need to test a point to see where I shade. All right. So for the next one, let's try another equation, or inequality, I should say. Graph y less than 2x plus 3 in a coordinate plane. All right, so step 1, we're going to graph our line. So make sure, hopefully this is more of a review for you right now. I have to remember the last lesson, 2.3, in which we graphed the equation line. So I start with my y-intercept, my b. My b is 3. Positive 3, I either move up or I move down. It's a positive 3, so my y-intercept goes here, positive 3, up 3. My slope is 2 or 2 over 1. So you go up 2, right 1. You could do the same thing again, up 2, right 1. If you wanted to, you could have went back to the y-intercept and went down to left 1, which is the opposite. Like I said in the past, I would do at least, I like to do 3 points in y-intercept form, all right? So here's our dots. Now, don't get hasty and just draw the line right through it originally because it might be dashed, right? So if I look, it's less than. Less than is not a solid line, it's a dashed line. So let's dash it. And usually I like to go through the whole plane here. All right, so there's my dashed line. Now what happens if, say you drew that line really quickly and you're like, oh man, it's dashed, I forgot about it. You could draw like track marks or tick marks, we call them. So if you forget to draw a dashed line, you see what I'm drawing here? You could do that to your solid line and I would know that that meant dashed, just in case here. All right, so here's our line. The next part we have to take care of is test a point. And like I said, I like to use 0, 0 as long as I can. And whatever point I pick, I actually plot it on the line, physically plot it. Here's 0, 0. Okay, 0, 0 is okay. I am allowed to test that point because it's not on my graph, on my line. So let's plug in 0 for x and y. Like I said, I like using 0 because usually the math is fairly simple because a lot of it cancels. So if you see me evaluating here, 2 times 0 is 0. I just get 0 less than 3. And I ask myself, is 0 less than 3? Yes, it is. So I put a little check. So I know I shade this half plane to the left or this half plane to the right, sort of. All right, so if it's true, 0, 0 is over here. I shade this side here. Okay, so there's my solution. All right, let's try one more example. Here, this one was in y-intercept. We're going to look at one that's in standard form. All right. Graph 3x minus 4y greater than 12 in a coordinate plane. All right. So I first want to, there's two ways you could really graph the line. You could get it in y equals. I know we're very, very comfortable with y-intercept form. But we could also, let's use our skills from the last lesson that we reviewed on graphing in standard form. So in order to graph, remember last time, we would plug in 0 for one of the variables and solve. I divide both sides by -4, so I get y, and I know when you divide by negative, then equality switches. Now, don't really worry. I know this is the only confusing part when you're changing this standard form into graphing for an inequality, is the fact that there's an inequality between it. It's the same as plotting this point. We'll take care of the inequality later. So that's the point we're going to graph. If we do the other one real quick here, I'll do the math to it. I'll plot them at the same time. These are my 2 points I'm going to plot. All right, so -3, 1, 2, 3 for the y. Plot that point here. Let's do black here. 4, 1, 2, 3, 4. Remember, it's a dashed line through those 2 points. Okay. And that's step 1, graphing it. Now we got to test a point. And if I look once again, I could do 0, 0, and I actually plot it on the graph. Remember, if you can't use 0, 0, you could pick any single point on. If I wanted, I could do 1, 1. If I wanted to, I could do, I don't know, -5, comma, -3. You could pick any point you want, whatever it is. Show me your test to it. I'm going to use 0, 0 again. Go back to the original. Make sure you show your work for your test. I get 0 greater than 12, which in this case we know is false. All right, so what happens when it's false? I don't shade where 0, 0 is, which is there. I shade the opposite plane. So here's my answer. It's not where 0, 0 is. All right. Finally, here's your last part. The video is going to cut out in a second, so just make sure you answer the problems. Do these on a separate sheet of paper, And that's it for today's lesson.